Good evening. Today's quote is by Aristotle. The worst form of inequality is to try to make unequal things equal. The worst form of inequality is to try to make unequal things equal. Today's word is plagiarism. Plagiarism is presenting someone else's work or ideas as your own without their consent by incorporating it into your work without full acknowledgement. Now, exercise 6.1, 20th sum, D part. Write the following expressions as sum or difference of logarithms. So we are supposed to use which laws? Log of m upon n is log m minus log n. Log mn is log m plus log n. Log of m raised to n is n log n. And what does ln stand for? ln means natural logarithm. I already explained this. LOGM, that is logarithm m, is common logarithm. Base is 10 used in log tables, and ln n means natural logarithm. It is used in calculus, that is limits, derivatives, and integration. And here base of logarithm is e. What is e? E is an irrational number. 2 less than e less than 3. So this is the D part. Natural logarithm cube root of x minus 2, right down, into 2x plus 1 raised to 4 divided by x plus 4 into root of 2x plus 4 and raised to 2. Okay. Basically, what is log of m raised to n? It is nothing but n log m. So in the very first step, I'm going to write 2 ln. Actually, it is not correct to use ditto mark, but here I am using that. So it is twice. Now, what is log of m upon n? It is log m minus log n. So here I am going to write this as ln. Cube root means raised to 1 upon 3. 2x plus 1 raised to 4 minus ln x plus 4 into what? 2x plus 4 raised to half. Why? Because I already told you that log of m upon n is log m minus log n. Now here I'm going to write twice. Here I'll omit one step. I'm writing this directly. It is 1 upon 3 log x minus 2 plus 4 log of 2x plus 1. Okay. Minus, actually, I should have written ln instead of log because this is natural logarithm. See, here they have written ln, but hereafter we will be writing log only. If we are doing calculus, base has to be e. If the base is other than e, then it will be mentioned like that. For example, 10 to 13, etc. So minus log x plus 4. I hope you get this step. Minus half log 2x plus 4. See why both the terms are negative? Let me explain. See the cursor. Basically, log mn is log m plus log n, but there is negative sign before that. So both the terms will be negative. And what is log of m raised to n? It is n log m. Now, if you want, you can open the bracket. Otherwise, this is the final answer. Right down. Today's sums are important. In fact, this topic is important. I repeat that for calculus, thorough knowledge of trigonometric formulae and logarithm is required. Of course, the topic function. Without function, it is not possible to function properly. 21st, write the following expressions as a single logarithm. A part, 5 log x plus 7 log y minus log z. Now it is n log m, log of m raised to n. So log of x raised to 5 plus log of y raised to 7 minus log z. That is log of x raised to 5 into y raised to 7 upon z. Reason, log m plus log n log mn, and log m minus log n is log of m upon n. Next, 1 upon 3 log of x minus 1 plus half log x n log m, log of m raised to n. So log of x minus 1 raised to 1 upon 3 plus log of x raised to half. Log m plus log n is log mn. Raised to 1 by 3 means cube root. Raised to half means square root. Right? C part, natural logarithm x plus 2 plus natural logarithm x minus 2 minus 3 natural logarithm x plus 5. Now log m plus log n log mn, n log m is log of m raised to n. And finally, what is log m minus log n? Log of m upon n. X plus 2 into x minus 2, you can keep this as it is. Or what is x plus 2 into x minus 2? X square minus 4. Right? 22nd, given that log 2 equal to a and log 3 equal to b, write log of root 96 in terms of a and b. Now express 96 as product of its prime factors. 96 is product of 2 5 times, that is 32 into 3. Now root means raised to half. So on right hand side also 2 raised to 5 by 2 into 3 raised to half. I hope you are getting this laws of indices. AB raised to m is a raised to m into b raised to m. Now, taking logarithm on both the sides, please do not read this as log into. So on RHS, what is log mn? Log m plus log n. Log of m raised to n is n log m. But they have given that log 2 is a, and they, according to them, log 3 is b. So 5 upon 2a plus 1 upon 2b, LCM is 2. So 5a plus b. As simple as that. 23rd, prove that. Let me explain the first part. Actually, we have already proved this, but once again, b raised to log a to the base b is, we have to prove that it is a. See, here base is b, base of logarithm is also b. Then what is the answer? Logarithm of which number? A. So a is the answer. So I begin with, let this value be x. I do not know the value, so I assume that it is x. Now index, whatever may be the index, log a to the base b is defined as logarithm of x to the base b. Now log a is log x. So a must be equal to x. That is, x must be equal to a. But we have put x for what? We have put x for this. So this, see the cursor, this must be the index. So b raised to log a to the base b is nothing but a. I hope this is clear to you. Let me explain, because you cannot do two things at the same time. So let me finish explanation part, then start writing. We have to prove that log a to the base, this b raised to m is the base. Log a to the base b raised to m is 1 upon n log a to the base b. You have to use common sense. On right hand side, base is b, and that is why we change the base to b. Now let me explain change of base rule. It is not at all difficult. See, logarithm of any number to the old base is logarithm of the same number to new base. B is new base upon log of old base to the new base. As simple as that. Again, log of, see, I'm not saying a, b, c, d, etc. Logarithm of any number to the old base equal to log of same number to the new base upon log of old base to the new base. Now in the denominator, what is log of m raised to n? N log m. But note that log b to the base b is 1. Why? Logarithm is the power to which base should be raised. B raised to which number is b? B raised to 1 is b. And that is why it is 1 upon n log a to the base b. Right now. Now C part, we have to prove that a raised to log b to the base c is b raised to log a to the base c. See, we have to prove this. That is to prove what? Index is defined. See, this is the index. Index is defined as logarithm of this to the base a. Okay. So to prove this means to prove this. Begin with RHS. Now, log of m raised to n is what? N log m. I repeat, log of m raised to n is this n log m. Next step is simple. We keep this as it is. Now for this log b to the base a, change the base to c. See the cursor. At present base is a. I will change this base to c. So what is the rule? Log b to the base a, log of any number to the old base is log of same number to new base, which is c, upon log of old base to the new base. Now log a to the base c gets cancelled. What remains is log b to the base c. This is nothing but left hand side. Hence the result. 24th, if fx is ax square minus bx plus 6, f2 3, f4 30, find a and b. Now fx is ax square minus bx plus 6. So what is f of 2? Value of the function at x equal to 2. Replace every x by 2 to get 4a minus 2b plus 6. I could have written equal to 3 directly because f2 is given to be 3, but here I have obtained these two separately. F4 comes out to be 16a minus 4b plus 6. It is given to be 30. So first equation is 4a minus 2b plus 6 is 3. That is 4a minus 2b is minus 3. Second, 16a minus 4b plus 6, 30. So we get this. I could have divided by 4, but in equation 1, coefficient of b is minus 2. And that is why divide by 2. Subtract 1 from 2. So that gives 4a equal to 15. So a equal to 15 by 4. Now put this in 1 to get b equal to 9. So this is the final answer. Right. 25th, solve for x. First, rather a part, log 2 plus log of x plus 3 minus log of 3x minus 5 equal to log 3. Now log m plus log n is log mn, log m minus log n log of m upon n. I hope you will not say this is baseless logarithm. This is baseless statement rather. How can logarithm be baseless? Since this is an equation, whatever is the base on LHS, valid base, same is based on RHS, simple. Now taking off the logarithm, please do not say dividing by log. That is ridiculous. If you want to write, you have to say that taking off OFF, taking off the logarithm, or if log a is log b, a equal to b. As simple as that. Now cross multiply, rearrange the terms to get x equal to 3. Right up. C part we are going to discuss. All these sums are interesting and important. Use rules of logarithm. Let me explain. Just a minute. Uh, 2 log x to the base 10 is given to be 1 plus log of x plus 11 by 10 to the base 10. Now this is very important. See, we do not want log. For that, every term should be in terms of log. Can I write 1 in terms of log? Yes, I can. Here base is 10, here base is 10. So I replace this one by log 10 to the base 10. Log of any number to the same base is 1. Logarithm is the power to which base should be raised. 10 raised to 1 is 10. So 1. Now what is log m plus log n? Log mn. So log of 10 into this. Now on LHS, what is 2 log x? Log of x square. So I can say that log A is log B. So A equal to B. Now solve this quadratic equation to get x equal to 11, x equal to minus 1. Let me explain. See, this is given. Therefore, we discard minus 1. Okay. But if we are given log of x square, we would have considered minus 1 also, because though x is negative, minus 1 square is 1. And here minus 1 plus 11 by 10 is what? Log of 1 by 10. Yes, it is valid. I hope you are getting this. But they have given log x. So in log x, x cannot be minus 1. So out of these two values, we discard minus 1 and we consider only x equal to 11. That's it. Now this is an important sum. Let me explain first, but do write the solution after the lecture. Log x to the base 2 plus log x to the base 4 plus log x to the base 16 equal to 21 by 4. Now change the base. You may ask me, but change the base to what? Say 10. You need not mention that. Again, if base is not mentioned, it doesn't mean baseless logarithm. It means base is the same. So log x to the base 10 upon log 2 to the base 10 and so on. Now log x can be taken common. So it is 1 upon log 2 plus 1 upon log 4 plus 1 upon log 16 is 21 by 4. Now 4 is 2 square. What is 16? 2 raised to 4. Now, just a minute. What is log of 2 square? 2 log 2. What is log of 2 raised to 4? 4 log 2. Now note that log 2 can be taken common from denominator. So log x upon log 2 is what? 1 plus half plus 1 by 4. Now, how do we add fractions? LCM 4. So 4 plus 2 plus 1, that is 7 by 4. So 7 by 4 into log x upon log 2 is 21 by 4. So log x upon log 2 is what? 3. 21 by 4 into 4 by 7. Okay. So log x is what? 3 log 2. 3 log 2 is log of 2 cube. So log x equal to log 8. And therefore x equal to 8. Now D part. X plus log of 1 plus 2 raised to x to the base 10 equal to x log 5 to the base 10 plus log 6 to the base 10. Now each term should be in log. So what is x? Can I write x as x into 1? Yes. Can I replace 1 by log 10 to the base 10? Yes. Because log of any number to the same base is 1. But why to select base 10? Because in remaining logarithmic terms, base is 10 only. Now n log m is log of m raised to n. So equation becomes, now it is log m plus log n, log mn. Same on right hand side. Now taking off the logarithm. So 10 raised to x into 1 plus 2 raised to x is 5 raised to x into 6. Now I will write this directly. I hope you understand this. What is 10? 2 into 5. So 10 raised to x is 2 raised to x into 5 raised to x. I hope you are getting this. Raised part as it is. Can I cancel 5 raised to x? To cancel means to divide. Yes, division is valid because 5 raised to x is not equal to 0. Okay. Now open the bracket. So 2 raised to x into 1 is 2 raised to x plus 2 raised to x square minus 6 equal to 0. I have omitted one step. It is better that we write 2 raised to x. After cancelling this, what remains? 2 raised to x into 1 plus 2 raised to x equal to 6. Open the bracket. So 2 raised to x plus square of 2 raised to x minus 6 equal to 0. Now you may say take 2 raised to x equal to say y or z. But here I am writing directly. I hope you understand this. So what are the factors? 2 raised to x plus 3 and 2 raised to x minus 2. If you do not understand this, you may say take 2 raised to x equal to y. So y square plus y minus 6 equal to 0. So y plus 3, y minus 2. Same. So that gives me 2 raised to x plus 3 equal to 0. That is 2 raised to x equal to minus 3, 2 raised to x equal to 2. But you have to use common sense. Can 2 raised to x be minus 3? No. Whatever may be the index, if base is greater than 1, greater than 0, I mean, not necessarily 1, not equal to 1, this is going to be positive. So 2 raised to x cannot be minus 3. Therefore, 2 raised to x equal to 2. 2 means what? 2 raised to 1. So x is nothing but 1. Right up. 26th sum. If log of x plus y upon 3 is half log x plus half log y, show that x upon y plus y upon x equal to 7. Now we begin with this. I have multiplied by 2. You may say, can we take half common from RHS and so on? Yes, that is also correct. Now 2 log of this is square of this, n log m log of m raised to n. What is log x plus log y? Log xy. Note that at this stage only you can say that as log a equal to log b, a equal to b. Simplify this. You get what? Now one student is asking why not to square this. See, I am just simplifying this. X plus y upon 3 square is x square plus 2x plus 2xy plus y square upon 9 equal to xy. Cross multiply. Rearrange the terms. So x square plus y square is what? 9xy minus 2xy. That is 7xy. Divide by xy. You may ask, how can we divide? Can x be 0? Can y be 0? No, because we are given log x and log y. Logarithm of 0 is not defined. So they are non-zero. So if you divide x square upon xy, that is x upon y, plus y square upon xy, y upon x equal to 7. So that's it for today. Actually, 27th is similar and is for homework.